Good morning, everyone, and welcome to another KETIV AVA for Fusion 360. My name is Brian Mongkolpooksuk, Customer Success Manager and Application Engineer here at KETIV Technologies. But anyways, thank you guys for joining me this morning on February 15th. This is our 38th Fusion 360 video, which is really awesome. We've come a long way, and we've gotten away from some of the rain here in SoCal. So today's it's a little bit less I guess rainy as it was the previous days. I think it's going to rain a little bit more, but thank you for the weather as well. But okay, so today we are going to be designing a model from scratch like we did in December. I brought this back again because it was a more requested, more popular video back in December from the feedback from you guys. So we're doing we're doing a similar, the same idea, but except with an assembly instead of just a part. And I want to show you guys the good habits and how you should go about creating an assembly from scratch, a reverse engineering, rather than just a part, and how to go about that. Because if you set it up right to begin with, it's going to be a lot less of a headache later down the line. So similar purposes to the ones in December. We want, if you have a competitor's model, like a physical copy in front of you, and you want to reverse engineer it, then this is a good webinar for you. I can help show how I do that. If your customer has the part, but they don't have a original file, like the 3D model of it, similar idea, that you can reverse engineer it and then have a 3D model for them. Or if you lost or broke the existing pieces, if you still have that piece in front of you that just might be missing a part or something like that, you can, once again, create the 3D model for it. So like, for example, if a house burns down, but you have the blueprint, you can just rebuild it up again with the blueprints. And lastly, learn how to properly start an assembly from scratch. So we're going to start from scratch in creating what you see here on the screen, which is one of those shake bottles that has the little metal spring inside that helps to break down the muscle milk powder if you go to the gym and things like that. We'll be creating this kind of bottle. We won't be doing every little detail for this because that'll take a couple hours to get it down to the nitty-gritty, but we'll get the general shape of it going to begin with for you guys here. And to recap, I wanted to update you guys on the one back in December. We did this part here on the left, which was the attachment head for the Dyson vacuum, and it was, I 3D printed and I was able to actually snap on perfectly, and it was actually able to suction with the vacuum. So that worked out really well. Just want to let you guys know that the tolerancing was it was pretty lenient for me. So I was able to get it on the first run. So I'm pretty happy about that. So moving forward, featured commands used. These are some of the commands that I use on this model. Create new component, that's just going along with how to start the assembly. Loft, so if you see like the bottom of the part is not perfectly circle, and it lofts up to the top part of the bottle, which is. And then we're using the Coil and Project 3D Sketch tool to create kind of our own custom threads, as well as the combine tool to kind of do a Boolean operation for the inverse of the thread, which is for the lid and the bottle. So I want to make sure you guys are leaving comments and things in the chat room so then we can, learn more about you guys, because I really want, just by leaving a sentence or two sentences about what you guys do, what you guys are using Fusion 360 for, it would be really helpful for what we can help decide to create for the next content for the webinar. So, and if you have any questions, of course, leave it in there as well, and I'll be looking at those at the end. So I'm going to go back to this slide right here, just so we can have an image of our shaker bottle here, and then we can move over here to Fusion. So this is the bottle that I made. Not all the little details, but I got the generic idea of it so you guys can see. And now let's go ahead and create a new model here. And I'm going to not explain everything. So if you guys are trying to understand some of the little details, those are easier to find on your own. But I'm just gonna go straight to some of the points here. So bear with me if I go a little too fast or a little too slow, but I want to make sure the majority of you guys are able to catch on. So first off, I have a caliper here with me that I'm gonna start measuring this bottle. But before we do any of that, let's have a good technique or a good habit of saving it right off the bat. So now when I save it, Brian's gem bottle. And if you try to 3D print this kind of bottle, it actually 3D printed parts won't hold water that well. Just let you guys know that. So I might 3D print this, but I won't be holding water in it, that's for sure. So I saved it as Brian's gym bottle. It named it up here as well. Now, since I know this is going to be at least 3 parts here for an assembly, I'm going to go over here to create new component. I'll call this one the bottle itself. I'll make sure that's not going to activate because I'm going to create a few more as well. I'll make a lid component. And I'm making sure this is active, so I'm not creating a component within these components there. And maybe one more like snap. And this is the snap piece is the white part of the bottle there that snaps on the top to stop the liquid from flowing out. So I have my 3 components here, and now we can get started with the design. So instead of just going straight in and sketching and extruding and stuff like that, which I admit that I also have a bad habit of doing for assemblies, what you'd want to do is go ahead and activate the component here. And next, we're going to go ahead and start measuring this. So I have a digital caliper here in respect to inches, 3.223. So hotkey C for circle, 3.323. All right, and then I'm going to offset this down to the next portion of it, which is 8.868, negative 0.868 since we're going down, which will give me, I'm going to hit P on my keyboard to project the original circle. And then I'm going to go down one more step here. .417. And create my final profile, which at the bottom is actually not a circle. It's going to be this shape. Well, first let me start with a circle, but then parts of it branches off to something else. So the diameter of, I guess, half the circle here is 2.819. And then this portion here, .595. And you can tell, so if I hit enter there, that this is way too long past the bottle. The bottle is actually thinner than the part of the top. So I'm like, why is it that? It's because I didn't divide this by 2 and I measured it. Or I measured the whole length, but I'm only putting in half of that length here. All right, now I'm just going to use some lines here to help build my profile, trim those off, mirror it over, just very simple techniques. I do need a mirror line, so let's go ahead and create one of those. And I'll make that construction line just because we're not actually using that line for the model itself. Mirror those two about that. And now we have our 3 profiles. So like I mentioned in the slides, we're going to use the Loft tool to be able to get this profile up to that profile and then that profile. So I'm going to loft here to here. But we don't actually want to loft the next step here, even though we can. Oops. We can loft there to there, but if you see now, if I try to create like an axis on this cylinder, oops, that was a different cylinder. If I'm trying to create on this cylinder right here, it's not letting me select that. That's because this isn't a perfect cylinder anymore because of the Loft tool. What you'd want to do instead, since I know this is the same exact circle as that, is extrude. So if I extrude this profile down to that body there, now if I try to create an axis through it, it allows me to select it because this is cylindrical. So keep that in mind. I picked that up while I was creating this. I was like, why am I not able to pick that up? It's because I used the loft between those 2 circles there. So next we are going to go ahead and create we'll go ahead and shell it first. And the thickness 0.91. And now I'm going to go ahead and create some of the lip on the outside to prevent it from the lid from screwing down past a certain point. So I can do this many different ways. Well, first off, I'm going to fix my view cube. It's showing the back is upside down. I'm just going to set the current view as the front. But yeah, let's go ahead and P for project. I'm going to project the entire body. And I know the lip starts exactly at this point here. It's going to go up and then it's going to go over a certain distance. .106. Yeah, so I'm hoping you guys pick up some things here that maybe you haven't seen before, that you can help add to your modeling techniques. And if you have, then just bear with me, maybe just a refresher that tool exists. But now I have a profile that we can use to maybe revolve. And instead of, I can either select that green line there, or I can select this cylindrical face to use as my axes. All right, and yeah, I could do little fillets and things like that, but we'll just go get the main bodies of it. So next we're going to want to create the threads that go in between this body and the lid. And just make sure every once in a while you look over here that you're activated in the component that you want to be working on. So I'm still working within the body, and everything that I create here will be saved in my bottle component. So now let's go ahead and use the coil command for these threads, because these threads aren't something that I can just get from Fusion, because they look a little bit more unique, the shape of it. So I'm going to go down 0.264 to start my coil. But if you have a standard thread, I would probably just go ahead and use that. But this one, it does not. Okay, so a few things I need to pull here. First off, let's get the thickness. Or this won't actually be the the thread that I'm using, this is actually going to be something I'm going to use to reference. So it'll make sense in a second here. 109. And then it revolves about 1.6. Because when I look at it from the side like this, the threads start and end around this part of the model. And then it's about on center. And I want to do a new body operation. And now I have, so if I go to, or this thread isn't exactly a triangle like that. It's actually like more of a one-sided, or one part of the triangle is a little bit not centered. It's not symmetric. So I'll be using this part of the model as reference. So I'll be projecting, include 3D geometry. And it doesn't quite matter exactly what plane you choose for this, because then you're just going to go choose 3D objects. So I'm going to select this 3D edge there. And now if I hide my coil, I have this 3D sketch I can use for reference for my upcoming sweep. So now we have this 3D coil there, or the sketch. Now I'm going to go ahead and go in and create the shape of what this actually looks like. And it's, I'll show you guys in a second here. 118. And I'm going to now go into my favorite tool, which is the plane along a path. It's like the satisfaction of dragging this guy around there. So now I'm going to start a sketch at the end of this path right there. Yeah. Okay, I'm just trying to get my view in position here. I'll just go ahead and project the outer edge of it, so I don't really need to get it perfectly into position. Because it was upside down. I just don't like working upside down like that. But I'm gonna project this, so now I can start building the profile off of that. So let me just draw a long line going through that, and then starting at the intersection of that, I can go out how far I measure it to be here, which is about the height of it. And then I'll just connect the two. And now we can do the sweep for the model. I'm just double checking that it's perfectly on the line there. So if I start there, and the path is that one there. And the guided surface would be that one to help us there. It's going to create this for us. Whereas before, I've worked on this earlier, if I just did a single path and I try to do the body there, it actually doesn't hug it perfectly. Well, at least you can see down here, it doesn't hug it perfectly because it doesn't realize or doesn't really care about that surface. So that's why I went ahead with the guidance surface and chose that surface there. So that's kind of more what the thread looks like. I might need to edit the model here a little bit. I think the plane was measured incorrectly here. So I measured to a different part of the plane. So let me just go back here to my design history, and the offset of this, I don't know if it will affect it or how will it affect it, but I want to move it up about 0.1. So it'd be minus 0.164 instead of 264. And thankfully that was able to update properly over here. So essentially that's my the custom thread there on this bottle. Still don't like the looks of it too much, so I might just make it look better for you guys here, just for the sakes of this. I can go back and measure another time here, but just want to make sure that this is going to look appropriate. So I'll go back to the 0.26. Yeah, okay. That'll just be what we'll be working with for now, but hence the custom thread portion. But we'll be using a Boolean operation now to create the thread on the lid itself. So now we're gonna go ahead and hop into the new component, and we can save in the meantime, like maybe, and it's good to have a description, good habit, definitely. Bottle underscore created. And of course, we can add fillets and things like that. But let's go ahead and now hop into and activate our lid. Now with the lid, I'm going to go ahead and create, use a Revolve to create it. I can reference the original body that I have here by projecting. And those I have as separate bodies there. So let's see, this part of the lid moves up about 0.038. And then goes out about 0.192. And then goes up 0.86 at a slanted angle, I can see here. So tab to go to the degree, say about 88 degrees, and maybe more than that, 85, 86. And then it goes up about 0.858. Okay, so now I'll go ahead and create a spline for the top part of my bottle. I'm gonna measure a little bit less because I don't want to burn through our time here, but essentially that is the, oops, so, see, maybe rushing is not a good idea here. But I want to get to the other portions of this for you guys to see. All right, so creating this top part of the lid, so then I can then I can do the Boolean operation. So I would be, measuring all of those points and maybe doing an offset of that, but I just want to get to the revolve here so I can have a new, or have this part of the lid. So next, I'm going to, now that I have the lid created, the inside is not yet threaded. So now we're going to do that Boolean operation with the combine tool. But if I do combine right now with my target body and using the bottle as my cutting tool while keeping the tools, if you take a look at the lid, all right, let's take a look here. Oh, sorry, I didn't combine the bodies here. So the threads and the bodies of my, let me go ahead and combine these first. So I went back to the bottle, I'm going to combine those, join. So now when I go back to my lid and do that combine, it should cut it for us. Let's do that again. Show my bottle, show that there. We'll go to combine the target body and then the tool body. Cut. Now if I had this bottle, there we go. So now I have the threads that were a Boolean of the bottle. But in addition, what you want to do, since if I do like a section analysis of this, we can see that they're essentially touching because they're the same part. I mean, it was just a Boolean operation, so they're like physically like touching each other. So what you'd want to do, and I don't know if I have time to show this, but it's going to be the, if you go back to the bottle, what I would recommend doing is actually going in and creating another body of this. I thought these were combined. I would go in and create another profile inside of the revolve here. I mean the sweep. I'll make another profile that's actually larger, than the existing one. Something along those lines. Sweep that around the coil, and then when you do the Boolean operation, since this is larger than the original thread, this will be able to give you kind of that tolerance for the bottle to twist on easier than having it perfectly the same size that it would be touching, and then it wouldn't give it any wiggle room for that. All right. So there's the lid, there's the bottle. And yeah, then you would add more things to the lid, like the top portions of it. These parts, these components. So let's get to just the joints of them, the combination of the two. So if we go back to the top level component here, now you can see both of them without one being a ghost and transparent. And if you try to move it, they if you pull them apart like that, they kind of don't move. Well, they move. They don't like twist off in a sense. It's not a cylindrical joint. Is what I'm trying to create here. So first off, if I move this piece, if I move this piece, nothing is grounded. It's all floating in space. You want to ground one of them. So I'm going to right click and ground the bottle, so I can't move that anymore physically. And then number 2, I want this guy to behave cylindrically. That's how the lead works. So I'm going to go over here to assemble, and I can create a joint, or I can create even another one, which is an as-built joint, because it's already in the position that I want it to be. So I'm going to select this component here. I want it to move in a cylindrical joint in regards to this body there and this position. So now it's giving me a little animation of what it looks like, and that's exactly how I want it to behave. So now when I move it manually, it behaves the way I want it to behave. And it works in respect to that this is a component, this is a component, this is the way it should be. One thing should be grounded, and et cetera, et cetera. Now, if you add a little bit of appearance to the 2 here, then you can start making it look more and more realistic. You can change display settings as well. And then the more you work on it, the more it'll become something like this, just by measuring and paying closer attention to detail. And yeah, and then when you want to get to the 3rd component, you would just activate it there to create that white piece. So you get something more along the lines of that. All right, so that was the majority of what I wanted to show you guys. Kind of didn't want to go too far over the time, but hope you guys understood the concept, and hope you guys picked up some things along the way that, like some of the tricks I use and even the errors I bumped into. Maybe you guys ran into the same thing. I just need to measure twice, cut once, as they say. So hopefully that was helpful for you guys. I'm going to take a peek here in the questions and see if any of you guys have any thoughts on that. Like we mentioned last year, that these will be once a month on Fridays, and Alex and I switch off doing our Fusion Fridays, as you guys may know. So Alex will be doing the next one. So if you guys have any suggestions for future topics, please leave it in the questions, or send me an email of a question you guys may have, and I'm more than happy to reach out to you guys and reply to that and help you guys as much as possible. So thank you guys for joining us. I can give it about 20 more seconds here for the questions. I don't see any coming in, but I appreciate you guys for joining me today. And our last, all these are being posted on our YouTube channel, so be sure to check them out. If you wanted to review something that you saw here that you want to use in your own modeling and design. Yep. Okay. I don't see anything else coming in here. So thank you guys again for joining, and I hope you guys have a good weekend.